common ion effect. In this video, we'll talk about what is the effect of common ion on solubility of any compound. So common ion in general, basically the common ion reduces the solubility of any ionic compound, the presence of a common ion. And what is a common ion? So for example, so far we have only been working with KSP and solubility of all ionic compounds in pure water. For example, if I take AgCl and we dissolve it in water, it would give us Ag ion and chloride ion. This is when this is happening in water. Okay, but what is a common ion? If in this solution, let's say from outside I add some chloride ion from outside, how is this going to affect the solubility? Remember, this is equilibrium, and this brings back Le-Chatelet principle. So if from outside I'm adding chloride, meaning I'm increasing the concentration of product, the reaction tries to do the opposite of it. It tries to reduce the concentration of chloride, and it can only do it by converting it all into solid AgCl. So that is the effect of common ion. If a common ion is present, the equilibrium shift towards the left. This shifting towards when the equilibrium shift towards the right, that means the compound is turning more soluble. So when it goes from solid to aqueous, it means it's more soluble. But when it goes reverse, that means it decreases the solubility. And that is what is common ion effect. And why is this occurring? This is occurring because of Le-Chatelet principle. It's not necessary that this chloride has to be added as a AgCl or as the same compound. It can be added in any form. Any chloride ion is going to produce the same effect. For example, when 0.2 molar NaCl is added to AgCl solution, the additional chloride shifts the equilibrium back to AgCl. So the equilibrium shift towards AgCl. So common ion, the common ion, what is common ion? Common ion is any ion in the solution that is supplied by more than one solute. That's the common ion. And what is the common ion effect? It is the effect which reduces the solubility of the ionic compound. For instance, if we look at solubility of PbCrO4, it dissociates to give us Pb ion and CrO4 2 minus ion. Initially, this is how much solid is present. But if Na2CrO4 solution is added to a saturated solution, so this solution right here in the front is already saturated. The question is, if more sodium Na2CrO4 is added into the solution, CrO4 is the common ion from here. So if we add more CrO4, the equilibrium, I'm increasing the concentration of CrO4, the reaction will try to use it all up, so it shifts towards the left, which means we will end up producing more solid. And that is what you see here on the right side. After CrO4 is added, more solid can be seen in the reaction mixture. And that is called the common ion effect. The solubility eventually decreases and more solid starts to precipitate out. So what effect would adding copper nitrate have on the solubility of CuS? Solubility of CuS basically means it depends on copper ion concentration and it depends on sulfide ion concentration. So if I'm adding copper nitrate means CuNO3 whole twice. I'm adding more copper into the solution and I'm adding more nitrate into the solution. Because I'm adding more copper, I'm increasing the concentration of product. The equilibrium will shift towards the left, which simply means that the equilibrium is shifting towards the solid, so solubility is becoming less. The solubility would decrease. How can we solve it in mathematical form? These could be the question. What is molar solubility of Ag2CrO4 in pure water? KSP is given to us. In pure water, it simply means, I don't care about this, 0, 0, plus 2x, x, which gives me 2x and x. So what is the molar solubility? Question is asking me to solve for x. Based on this, 2x Ksp is going to be concentration of Ag squared times CrO4 2 minus. So Ksp is going to be equal to 2x squared times x, which gives us 4x cube. So from here, x is going to be Ksp divided by 4 to the power of 1 by 3, which Ksp is given to us. So we can plug in the value here, solve for x, and that would be our answer. And that gives us the answer of 6.5 times 10 raised to power minus 5. That is the solubility of Ag2CrO4 in pure water. Part B was, what is the molar solubility of Ag2CrO4 in 0.1 molar AgNO3 solution? Ksp is given to us. The difference here is, in this case, Ag2CrO4 is still my solute, but now I'm not making it in water. We are making it in a solution that already has some Ag and already has some nitrate. 1 AgNO3 will give me 1 Ag, and 1 AgNO3 will give me 1 nitrate, which means 0.1 would give me 0.1 of this and 0.1 of this. And the ion that I'm interested in, the X, I'm interested in this. So if I write the expression for it, Ag2CrO4 solid dissociates to give us 2 silver ion, 1 CrO4 ion. I do not care about this. I'm solving for X. Initially, I do have some silver in the solution. That is what is common ion. So initially this is 0.1, CrO4 is 0, because initially this is the common ion that is present. This would be plus 2x, this would be plus x. So equilibrium is 0.10 plus 2x, equilibrium is x. So now the expression is Ksp is silver squared times CrO4 2 minus, which means I can rewrite this as 0.10 plus 2x whole square times x, and Ksp is given to us right here. So we just have to solve for x. Now if I keep this 2x, my equation will become quadratic, which is very difficult to solve. So again, to make it easier for us to do the math, we can make the assumption here that 0.10 plus 2x is almost same as 0.10, because x is a really small value. So our equation is reduced to Ksp 0.10 squared times x. So x will be Ksp divided by 0.10 squared, which is 1.1 times 10 raised to the power minus 12 divided by 0.10 squared, which basically gives us x as 1.1 times 10 raised to the power minus 10. So if you compare your x, which is molar solubility from between part A and part B right here, we can see that the part B is a lower value, which shows us that solubility has decreased because of presence of common ion. The other question is this, part C, what is the solubility of Ag2CrO4 in 0.1 molar Na2CrO4? This time, what is the common ion? This gives me Na, 2 Na ions, and this gives me 1 CrO4 ion, which means if I have 0.1 of this, I have 2 times of that. I have 0.200 of sodium and I have 0.100 of CrO4. But I'm interested in Ag2CrO4 solid dissociates to give us Ag plus 2 and 1 CrO4 2 minus. I'll let you guys solve this on your own, but remember, in this case, again, I need the ice table since I'm solving for x. Ag is going to be initially 0, because this time the common ion is not Ag. common ion is CrO4. So this is 0.10 plus 2x, x, 2x, and 0.100 at equilibrium is going to be 0.100 plus x. Now same, this would KSP is going to be 2x whole square times 0.100 plus x, but we'll assume this plus x basically means it is 0.100. So from using that, we will solve for x again, and if we solve for x from this expression, it comes out to 1.66 times 10 raised to power minus 6. So that is the effect of having a common ion on solubility of any salt. It always decreases. There are some more questions on the slide. Again, I'll ask you guys to please pause the video, practice this on your own, and then compare the answers that you see on the slide. If you have questions, you can ask me. The next concept is, what is the effect of adding acid or base on the solubility of some of the salts? For example, what will be the effect of adding acid to calcium carbonate? Is it going to decrease the solubility, increase the solubility? For this, again, we go to common ion effect. Calcium carbonate will dissociate to give us calcium ion and carbonate ion. Now, what will be the effect of adding acid? What is an acid? An acid is something that donates protons. So if I add protons into this, what we have to see is, do protons interact with calcium, or do they interact with carbonate in any way? Calcium, they will not interact because proton is positive, calcium is also positively charged, so two positives are not going to interact with each other, they repel. But proton interacts with carbonate in order to make carbonic acid. H plus carbonate, you will interact to give us H2CO3, which means by adding some acid, we are removing some carbonate, because carbonate will interact with H, which means I have less carbonate left here in the equilibrium. So I'm reducing the concentration of carbonate in the reaction, which means the equilibrium will try and shift so that it can increase carbonate concentration. So the equilibrium here is going to shift towards the right, which means solubility is going to increase. So the effect will be that it would lead to increase the solubility. So if we do anything that increases the product concentration, it would reduce the solubility. If we do anything that decreases the ion concentration, it would increase the solubility. And we can try, for example, this magnesium hydroxide. We are interested in this dissociation of magnesium hydroxide in water. It dissociates to give us magnesium ion and hydroxide. What is the effect of adding base? What do bases do? Bases either absorb, they react with protons, or they release OH minus, right? Base like NaOH. NaOH is going to release more hydroxide. So if I'm adding more hydroxide, I'm increasing the hydroxide ion concentration. The reaction will try to use that hydroxide and it would shift the equilibrium towards left, which means it will form more solid. So it will reduce or less solubility. It would reduce the solubility. What is the effect of adding acid? If we add acid into it, acid is proton. Protons like to react with hydroxide, so proton and OH minus will react and will make water, which means to this equation, what we are doing is we are getting rid of the hydroxide, because the hydroxide that is interacting here comes from the hydroxide here, which means I'm reducing hydroxide ion concentration. External stress is reducing, the reaction will try to make more, and it will make more by shifting towards the right. So it will increase solubility, because more, when it goes to right, more solid will turn into ions, which means solubility is increasing. That is the effect of having any common ion, adding common ion, removing common ion from the on the solubility of any ionic compound. Again, there are more questions. More question, for example, this AgCl. What is the effect of adding H ion? Okay, the question says adding H ion has no effect on the solubility. Why? This is, we are adding H ion. The way H ion will interact with any of these is, only thing H can do is it can interact with something negative. So if H interacts with something negative, it will give you HCl. But HCl is a very, very, very strong acid. So it is very difficult for us to make HCl. Whenever HCl would be made, it would dissociate back, which simply means that this forward reaction is not going to happen, because HCl is such a strong acid that it would always dissociate. It is almost impossible to make this acid by doing this particular reaction. That is why if you add H into it, it is not going to affect the reaction, because H does not interact with silver ion, and it also does not interact with chloride. So it is not going to affect the concentration of either or products. That is called the common ion effect, and that is how we can figure out what is the effect of adding any external chemicals into your solution, including acids or bases.